All right, guys, before we start, I wanted to show you a new thing I figured out. Look, here's a positive x, right? If I hit the flip button, it makes it negative. If I hit the flip button, it'll make the negative positive, which is great. This is going to come in handy later on for sure. Okay, now I want to set a precedence for how we're going to do multiplication from here on out. Which is this idea of a rectangle of columns and rows. So kind of um, like this. Here I have four columns and I have three rows, four rows. And that's showing multiplication. I'm not doing this problem yet. I'm not doing this problem. But it's kind of like this idea of I have this kind of length this way, right? And then I have this kind of width or length this way. And, well, here, right? And multiplying 4 times 4 will give me 16, and there's 16 in here. So this is the basic idea of how we multiply, and we're going to apply it to tiles. So what do I mean? What I mean is I'm going to have like going across this 4x. Okay, there's 4x. And then what I'm going to do is I'm going to copy all of it, and I'm going to go down for 3 rows. 1, 2, 3. There it is. So the answer there is 12x. I'm not going to spend too much time on this. I think this should be pretty reasonable. Um, I'm not even going to do a sample problem for this. I'll go ahead and do a few practice problems, and then we'll move on to some harder ones. So what do we do with like x times x? So what I'm going to do, this is why it's nice to have the horizontal and also the vertical. Because what we can do is we can line them up like this, guys. All right. X times x means an X amount of columns and an X amount of rows. And what we can do is we can just fill that in right there like that. Now, some people, they won't do that. They'll have it kind of like spaced off to the side here. And then this just kind of fits in there. Like this is just a label saying this is there's this many columns. And this is just a label saying this many rows. We'll stick with that model. All right. All right, so how would we do a problem like this? 8x times 3x. We're going to do the same thing where we're going to have 8x's across. Let me keep making more. 3, 4, 5, 6, 5, 6, 7, 8. All right. And then we're going to have 3x's down. So 1, 2, 3. Good. Now, let's see what we have here. All right. So right here, as an x times an x, that's an x squared, right? And right here is an x squared. And right here, in fact, you can see anywhere we have an x times an x, we have an x squared. Another way to look at that is it's what fits in here, right? And we'll keep going with that. And the answer is 24x. Because we have x squared, sorry, x squared. Because we have 24 of those blue blocks, which represent the x squared, because they are x wide and x long. Makes a square. All right, do this next one with me. So we're doing 3x times 2x. To do this, we're going to lay out 3x columns across the top. And then 2x's going down. All right, I'm going to fill in the spaces. There we go, right there. Right there. X times x just makes x squared. Boom, boom, boom. And you can draw this in your packet. The answer is 6x squared. Now, one quick thing I do want to show you is up here where it says variables. You can switch it to 2 or 1. And if I switch it to 2, that will help me. Look, I've got y squareds and I got y's and 1s and xy's. Ooh, ho, ho, ho. So let's see how this helps us. If we have a problem, oh, there was one that looks like this. I have, excuse me, x times y, excuse me. Okay, like that, right? Then when I have x times y, the only thing that's going to fit right in there is an xy. So the answer is xy. All right, easy enough, easy enough. Woo, but what about this guy right here? 6x times 7y. Let me set this up. Here we go. All right, we're going to go with this one. Easier to set up. 3x times 2y. You can see I have 3 x's going across the top. And that just means I will have that many columns. I don't know how much is in x, but I will have that many columns or that length if I'm making a rectangle, right? And then I will have this width, the y width. I'll have 2 of them. Okay. So let's start building this. We see that only an x y when we have x times y. I'm going to rotate that. There we go. See, look how it fits because x times y is an xy, right? And I'm just going to keep duplicating that, bring it down, and the answer is 6 xy's. There are 6 of those xy blocks. Simple as that. So make sure you put that into your packet where I prompt you to. All right, just in case, I want to go back for just a second in case this is confusing at all for any of you. Look, what we're making here, I just want to make it clear. What we're making here is a rectangle that has this width, 2 unknown widths, and then this length of 3 unknown lengths. And that's how we're finding, you know, what is in this rectangle. It's 6xy's. It's just like finding the area, length times width, right? It's the same thing we would do if let's say we had 3 times 2. Okay, 3 times 2. I would line it up like this, and I'm just looking at those as like headings, right? And let me just do this as a slightly different color so you can see what I mean here. All right, so then I'm just going to so this is just like writing 2 and then writing 3 up here is what these are. They're labels. They aren't the actual thing we're looking at, okay? I want to make that clear. It's really important. So here inside this dark inside 3 for that first row and then 3 in this second row. That darkness right there is the answer. That darkness, the answer is 6, right? We're just looking at this right here as like a heading, just like it is here, and this 3 as like a heading like it is here. And what I mean by heading is it's just telling us the length of that rectangle so that we can see how much area is in that, how much blocks are in that area. That's very key, guys.